This is the ShopBot. The idea is that you design on the computer in a CAD, computer-aided design program, and that is what and where you want something to cut out. Then you'll use a CAM software, which is how you want it to cut out. Do you want it to V-carve? Do you want it to pocket, go to one depth, or do something that's truly 3D? And then you arrange the toolpath, and the toolpath sends the code from the computer to the machine. And the way these all work is to go back from Cartesian geometry. So you thought all that stuff you had in middle school where you had X and Y and Z, and this is the real application. Toolpaths that you can do with a ShopBot are 2D, and they're, even though the machine is really moving in 3D, what it is doing for the actual toolpath is it is going to one depth and machining everything at that one depth. So you can pocket things with that, you can do dados with it, you can cut out things, you can drill holes. Those are all considered 2D files, because once the bit, usually an end mill bit, gets to that level, it's doing all of its work at that level. This is called a V-carve, and a V-carve is, the shape of the bit is a V-bit, and so it's usually going along the center of a closed line here. But when it gets to the corners, it is pulling up and out, so your corners are very sharp, and so that you get the results because of the shape of the bit and the 3D movement of the tool. So the Z is constantly moving up and down, and if it's wider, the bit is being plunged deeper into the material. If it's narrower, it's pulling up and out. This is a true 3D. So this is a ball nose bit, and the Z is constantly moving up and down, and when it does a step over, it may only do an 8% step over, which means that it is recarving 92% of what it did before. But if you do it like that, you're letting the machine do all the work. So the timing of all of these things is going to be very different, and the software that you use for the CAM, the computer-aided machining part of these, is going to be different for the 3D than it is for the V-carving and the 2D. So this is a change in bits. We've got a V-bit on the edge and then a flat bit here. This might take 20 minutes to do. This might take 4 to 6 hours to do.
I'm Bryan. I'm in the R&D group at ShopBot, so I have the pleasure of designing these tools and designing accessories for them. My background is most relevantly, I started as an industrial designer, got a degree from here, NC State. So I've been around here in the Triangle a good little while. And NC State is where I first started getting into ShopBots. At the time, over in the basement of Liaison, we had a PRT 4x8 full-size gantry tool. But what the HandyBot is it's a miniaturized version of our larger tool, and it, instead of putting material onto a fixed bed, you're putting this dynamic tool onto your material. So what that lets you do is it lets you take things like this workbench and carve right on it. So if you wanted to carve some message like clean up after yourself, you could do that right on the bench instead of having to figure out a way to bring the bench top onto the larger machine. So that's where the original sort of novelty came in, was how do we make this thing cut through its own bottom so that we can do this sort of these larger pieces. And then, as Sallye mentioned, that allowed you all of a sudden to be able to do much larger things by tiling. So you might learn eventually about how the software can break your larger designs into smaller jobs, which can then be run sequentially to create sort of almost like quilt work, large jobs. Sallye was talking about the indexer earlier. We came up with just a quick way of blocking up the HandyBot, putting a rotary indexer beneath it, so then you can do all the things you can do with the desktop at a lower price point. So in this case, this was what we would call a 3+1 machining, doing a little, I think that's like a Dodge Charger, Challenger, one of those, where we're doing all of our machining on one plane of the car, rotating 90 degrees, doing all of our machining, rotating 90, and in that way you can access more faces without having to manually flip the part.
What's the Z travel on that?
You can travel 4 inches. And another thing that CNC ShopBots are really good for is sort of iterating. So I talked about building in complexity into the part. Another thing, once you have your 3D model, if you want to iterate, modifying a 3D model as a starting point is a lot quicker than, let's say, if I was doing this by hand, starting from scratch. So in that way, we evolved the HandyBot a few different times over the course of just a few months, pretty radically. It might not look like it, but this early one it used a clip joint system where the joinery was actually these sort of compression clips that when pushed into a slot, they expanded and it held itself together nicely. We found out that these motors were too powerful for that joinery system though. So we moved on to the intermediate step. We had a gluing operation at one point that was a nightmare, and then we moved on to the current joinery we're using. And along the way, we shuffled lots of things: electronics location, size, travel, and all of that is really quite straightforward once you have that initial 3D model. The way we make these is quite interesting too, and this is something that eventually you might get in touch with us and we can help you sort of develop these sorts of processes. We use a zoned vacuuming system where that pump in the lower center, it pulls just about 20 inches, and the parts of the HandyBot themselves are laid out in a way that the gasketed areas with the grids are holding those parts. And we know, since we're always cutting the part in that exact location, we're not going to get into our gasketing. So we're pulling a strong vacuum from inside that gasketed area. It's holding the part flat and tight, so we don't have to use tabs, and we don't have to deal with any sort of bad edge quality. All of our edge quality ends up very nice. And this sort of standardizing the system allows us to think about sort of distributing the manufacture, perhaps eventually, of these tools.